I am Radhakrishna, your mathematics teacher. Today we are going to continue our topic circles, fourth lecture. Okay, and let us have a recap of the previous class first. The equation of the tangent at a point x1, y1 to the circle s is equal to 0 is s1 is equal to 0. What is s1 is equal to 0? If s is x square plus y square plus 2gx plus 2fy plus c is equal to 0. This is the general equation of a circle in the standard form, and S1 is xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0. So, equation of the tangent to the circle at P x1 y1 is given by this formula. Okay. Now, let us move on to next point. Equation of the chord of the circle s is equal to 0, which is bisected at P x1 comma y1 is s1 is equal to s11. Suppose a circle is like this and this is a chord. If the midpoint of the chord is P x1 comma y1, the equation of the chord is given by the formula s1 is equal to s11, right. Next, if the line y is equal to mx plus c is a tangent to the circle x square plus y square is equal to r square, then c square is equal to r square into 1 plus m square. Okay. If we take a circle, if a line is a tangent, what is the condition? Perpendicular distance from the center is equal to radius. Perpendicular distance from the center of the circle to the line should be equal to radius. Then using that condition, you will get c square is equal to r square into 1 plus m square, right. The slope form of the tangent to the circle x square plus y square is equal to r square is y is equal to mx plus or minus r root 1 plus m square. If you substitute this c as plus or minus r root 1 plus m square in y is equal to mx plus c, then you will get this. For any value of m, this is a tangent line to this circle, x square plus y square is equal to r square, right. Next point, if the line Lx plus my plus n is equal to 0 is a tangent to the circle x square plus y square is equal to r square, then the condition is n square is equal to r square into L square plus m square, and the corresponding point of contact is minus r square L by n minus r square m by n, right. Next, the parametric form of the tangent of the circle x square plus y square is equal to r square is x cos theta plus y sin theta is equal to r. For any value of theta, this line is a tangent to this circle. Okay, whenever you want to consider a tangent to the circle x square plus y square is equal to r square, you can take x cos theta plus y sin theta is equal to r, or we just now we discussed the slope form of the tangent, we can take that equation. Okay. Next, the slope form and parametric form of the tangent to the circle x minus h whole square plus y minus k whole square is equal to r square is slope form of the tangent is y minus k is equal to m into x minus h plus or minus r root 1 plus m square, and parametric form of the tangent is x minus h into cos theta plus y minus k into sin theta is equal to r, right. Now, let us discuss some problems on this previous theory. Find the equation of the tangents to the circle x square plus y square minus 2x plus 4y plus 1 is equal to 0, which are parallel to the line 3x minus 4y plus 5 is equal to 0. Suppose this is a circle and some line is given, and parallel to that line how many tangents can be drawn? 2 tangents, one tangent like this, another tangent here. Now, how to find the equations of these 2 parallel tangents? This line is 3x minus 4y plus 5 is equal to 0. Okay. Now, I will show it in the diagram and explain. 3x minus 4y plus 5 is equal to 0 is a line and 2 parallel tangents are drawn. Then, how to find the equations of the tangents? Now, let the tangent to the circle be 3x minus 4y plus c is equal to 0. Since it is parallel to this line, only constant term will be different. Then, we have to find the values of c. What is the condition if a line touches a circle? Perpendicular distance from the center is equal to radius, and center of the circle is 1 comma minus 2, minus g comma minus f, that is 1 comma minus 2, and radius of the circle is, if you calculate by the formula root over g square plus f square minus c, you will get 2. Then d is equal to r is the condition. Then what is d? Mod 3 into 1 minus 4 into 2, that is 8, plus c upon root over 3 square plus 4 square, that is 5. All of you are aware of the perpendicular distance formula, and this perpendicular distance should be equal to 2. Then if you calculate the value of c, mod c plus 11 is equal to 10. Then opening the mod, you will get c plus 11 is equal to plus or minus 10. Then c is equal to, if you take plus 10, you will get 10 minus 11 minus 1, or if you take minus 11 minus 10, minus 10 minus 11 is minus 21. So, there are 2 values of c. So, substituting c here, you will get the equations of the tangents are 3x minus 4y minus 1 is equal to 0 and 3x minus 4y minus 21 is equal to 0, right. Now, next question. If the line 2x plus y minus 3 is equal to 0 intersects the circle x square plus y square minus 4x minus 6y plus 4 is equal to 0 at A and B, find the midpoint of AB. Consider the circle like this, and this line is given. The given line intersects the circle at A and B. Then we have to find the midpoint of AB. For finding the midpoint of AB, there are 2 methods. One is, first you take midpoint as p x1 comma y1 and write the equation of the chord of the circle having midpoint at p x1 y1. What is the formula? Equation of the chord with midpoint p x1 y1 is S1 is equal to S11, and then write S1 is equal to S11 xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c is equal to S11. S11 is x1 square plus y1 square plus 2gx1 plus 2fy1 plus c, and substitute the values of g, f and c, you will get xx1 means xx1 plus yy1 plus what is g? G is minus 2. So, here write minus 2 and here f is minus 3. So, substituting f, you will get minus 3 into y plus y1 and plus c, c is 4. So, substituting c, this is 4. In the RHS also, you have to substitute 2g, 2f and c. Now, what is 2g? 2g is minus 4 and 2f is minus 6 and c is 4. Now, you can write this equation as x into x1 minus 2 plus y into y1 minus 3 is equal to x1 square plus y1 square plus x1 square plus y1 square minus 2x1 minus 3y1 4 cancels. So, now comparing this equation and this equation, x1 minus 2 by 2 is equal to y1 minus 3 by 1 is equal to x1 square plus y1 square minus 2x1 minus 3y1 upon minus 3, comparing with this line. Then we have to solve, but this method is too long. So, we can use the property of a circle and get the answer very quickly. What is the center of the circle? Center of the circle is 2, 3. Now, all of you know that perpendicular from the center of the circle to the chord intersects the chord at its midpoint. So, directly P will be the midpoint, P will be the foot of the perpendicular from the center on the line. So, I will apply foot of the perpendicular formula and get the answer very quickly. Let us see. This is the circle and this is the chord. I want to find foot of the perpendicular. If foot of the perpendicular is h comma k, and all of you must be aware of the formula for finding foot of the perpendicular from a given point to a line. Center is 2, 3, and what is the formula for foot of the perpendicular? H minus what? H minus 2 upon coefficient of x 2 is equal to k minus 3 upon 1 is equal to minus of substitute 2, 3 in this equation, 2 into 2 4 plus 3 minus 3 divided by 2 square plus 1 square, that is 5. The formula for foot of the perpendicular is h minus x1 by a is equal to k minus y1 by b is equal to minus of ax1 plus by1 plus c by a square plus b square. If the line is ax plus by plus C is equal to 0. If you want foot of the perpendicular from a point x1 comma y1 to this line, if the foot of the perpendicular is h comma k, then the formula for h comma k is given by this formula. I used it. Now after calculation we get h is equal to 2 by 5 and k is equal to minus 11 by 5. Let us check. This is coming out to be minus 4 by 5, cross multiplying by 2, h minus 2 is equal to minus 8 by 5. So h is equal to 2 minus 8 by 5. How much it is? 2 by 5. Similarly, we get k is equal to minus 11 by 5, right. Now next question. Find the locus of the midpoint of the chords of the circle x square plus y square minus 4x minus 6y plus 4 is equal to 0, which touch the circle x plus 2 whole square plus y square is equal to 1. So let us see the diagram. Suppose this is the first circle. If a chord of this circle touches the second circle, then there are so many chords which can be drawn touching this second circle like this. Now you want the locus of the midpoints of all these chords. If you join all these chords, you will get a curve. We want the equation of that curve. So how to proceed? First, this is not the diagram. The diagram is this. Okay. Now I will take midpoint of some chord as p x1 comma y1. In any locus problem, usually we start with a p x1 y1 as a point on the locus. So I have taken a point p x1 comma y1 as midpoint of a chord of this circle. Okay. Then what is the equation of the chord? Just now we discussed the formula just before the class. It is S1 is equal to S11. So equation of the chord is S1 is equal to S11. What is S1? Xx1 plus G into plus YY1 plus G into x plus x1, that is minus 2 into x plus x1. Similarly, f into minus 3 into y plus y1 plus 4 is equal to S11. S11 is x1 square plus y1 square minus 4x1 minus 6y1 plus 4, right. Now cancel the common terms, 4 cancels, and here minus 2x1 cancels and minus 3y1 cancels. So we get xx1 plus yy1 is equal to x1 square plus y1 square minus 2x1 minus 3y1. So this is the equation of the chord having midpoint at px1 y1. Now how is this chord? It is a tangent of the second circle. What is the condition for tangency? D is equal to R. Perpendicular distance from the center is equal to radius. What is the center of the circle? Minus 2 comma 0. Center of the second circle. Center is minus 2 comma 0, and what is the radius? Radius is 1. R is equal to 1. Now applying D is equal to R condition, perpendicular distance from the center is equal to radius. what is the perpendicular distance from the center to this line? Perpendicular distance from this center to this line is mod minus 2x1 plus 0 minus of x1 square plus y1 square minus 2x1 minus 3y1 by root over x1 square plus y1 square is equal to radius of the circle 1. Then cross multiplying and simplifying, we get x1 square plus y1 square cross multiplying this and squaring. X1 square plus y1 square is equal to, what will be the RHS? X1 square plus y1 square plus 2x1 minus 2x1 will cancel, you will get plus 3y1 whole square. So, this is going to be the locus of the midpoint of this circle with respect which is locus of the midpoint of the chords of this circle which are tangents to the second circle, right. Now, let us see the same steps. S1 is equal to S11 is the tangent, and we have written the equation of the tangent xx, this is minus 2, and then perpendicular distance from the center is equal to radius, we get this, and on simplification, what is this? This is d is equal to r, let us check. Okay, we have made a calculation mistake in the previous calculation. Here, if you simplify this, you will get x into x1 minus 2, okay, plus y into y1 minus 3 is equal to x1 square plus y1 square minus 2x1 minus 3y1. Now, apply d is equal to r, perpendicular distance from the center. Center is, what is the center of the circle? Minus 2 comma 0, and radius r is equal to 1. So, d will be perpendicular distance from this point to this line is minus 2 into x1 minus 2, next plus 0 into y1 minus 3, 0, minus of this by root over x1 minus 2 whole square plus y1 minus 3 whole square. So, finally, cross multiplying and squaring, we get this locus. So, finally, after getting the condition, if you replace x1 by x and y1 by y, we get the locus of the point. So, locus of the midpoint of the chord of the first circle which is tangent to the second circle is given by this equation. Okay. Now, moving to the next question. Find the locus of the midpoint locus of the point of intersection of tangents to the circles x square plus y square is equal to a square and x square plus y square is equal to b square, which are mutually perpendicular. I am going to explain in two methods. In method 1, let us assume that A is less than B. So, both are concentric circles, center of this circle is origin and center of this circle is origin. If the centers of two circles are same, they are called concentric circles. So, these two are concentric circles. So, if A is less than B, let us assume A is less than B, then we get smaller circle with radius A and larger circle with radius B. Okay. Now, draw a tangent to one circle which is perpendicular to a tangent of the second circle, then we want the locus of the point of intersection. So, let us assume that point of intersection of these two perpendicular tangents is P x1 y1. Now, the diagram is, this is smaller circle, this is the larger circle, P x1 y1 is the point of intersection of the tangents, origin is center, radius of the smaller circle is A, radius of the larger circle is B. Now, let the tangent to the smaller circle be taken in slope form. Y is equal to mx plus or minus a root 1 plus m square. Denote the equation by 1. Now, we have to draw a perpendicular tangent to the larger circle. If you want to draw a perpendicular tangent to the larger circle, what will be the radius, slope of the tangent? It should be perpendicular to this line, and this line has slope m. So, the perpendicular line should have slope minus 1 by m. So, taking slope minus 1 by m and using slope form of the tangent to the larger circle with radius b, we have to replace a by b and m by minus 1 by m. Then what do we get? Equation of the tangent to the circle x square plus y square is equal to b square, which is perpendicular to the above line, will be y is equal to minus 1 by m into x plus or minus b root 1 plus minus 1 by m whole square is 1 by m square. Now, I will simplify it. You can cross multiply by m, taking m LCM, cross multiplying by m, taking minus x this side, it becomes x plus my is equal to b root 1 plus m square. Now, denote this by equation 2. Now, these two lines 1 and 2 intersect at px1 y1. Okay. If the point of intersection of the equations 1 and 2 is px1 y1, then substituting px1 y1 in the two equations, first equation is y1 minus mx1 is equal to a root 1 plus or minus a root 1 plus m square, and substituting in the equation 2, we get x1 plus my1 is equal to plus or minus b root 1 plus m square, right. Now, what I will do, if I want the locus of px1 y1, I should eliminate the variable quantity. What is the variable quantity here? M. M varies. These two lines vary like this, then m varies. So, if you eliminate m from the two equations and get the direct relation between x1 and y1, that will become the locus of p. So, what will I do? I will square on both sides and see. Now, squaring and adding, in order to eliminate m, squaring and adding the two equations. Squaring the first equation, what is the first equation? y1 minus mx1 is equal to plus or minus a root 1 plus m square. Squaring this LHS, we get y1 square plus m square x1 square minus 2mx1 y1 is equal to a square into 1 plus m square. Similarly, squaring the second equation, we get these two. Now, adding these two, why should we add? This term gets cancelled, and see, we get 1 plus m square into x1 square plus 1 plus m square into y1 square is equal to a square plus b square into 1 plus m square, and you can now cancel 1 plus m square on both sides. So, m is eliminated, it becomes x1 square plus y1 square is equal to a square plus b square. So, now replacing x1 by x and y1 by y, we get the locus of the point P x1 y1. So, the locus of P is another circle, x square plus y square is equal to a square plus b square. But this method appears little long. So, let us discuss another method, method 2. In this method, again take the same diagram. This is radius of the smaller circle A, this is the radius of the larger circle B. They intersect at Px1 y1. Now, observe it, angle between tangent and radius is always 90 degrees. So, this is pi by 2, similarly this is also pi by 2 and this is pi by 2 because tangent should be perpendicular to each other. If these three angles are pi by 2, then this is also pi by 2. Then what is the figure formed? It is a rectangle. So, if this is A and this is B, then this is A, this is B. Then what is the length of the diagonal? Length of the diagonal is OP. OP is equal to root over A square plus B square, is it not? By Pythagoras theorem. Then OP square is equal to A square plus B square. If you take P as x1 y1, O is origin, no? So, OP square will be x1 square plus y1 square, distance formula, is equal to A square plus B square. This method is very, very simple. Then the locus of P is x square plus y square is equal to A square plus B square. Okay. Now, moving to next question. Find the locus of the point of intersection of the tangents to the circle x square plus y square plus 6x minus 4y minus 3 is equal to 0, which intersect at an angle 60 degrees. Suppose this is a circle, it has center minus 3 comma 2 minus g minus f, and what is its radius? Radius r is root over g square plus f square minus c. G square is 3 square, 9 plus f square is 4 minus c is plus 3. How much are you getting? This is root 16 is 4. Radius of the circle is 4. Now, if you take two tangents to a circle, two tangents to the circle which intersect at an angle 60 degrees. This angle is 60 degrees. Then what is the locus of this point? So, the tangents will vary, but angle is always 60 degrees. Now, if you move these tangents like this, you can easily say that the locus of P is going to be another circle. Can't you imagine? You can visualize these two tangents moving like this. Okay. Then P will be moving on another circle with center minus 3 comma 2, that you can visualize. Now, what is the radius of the circle? What is the radius of the circle? We got to know that center of the circle is, center of this locus is going to be same center minus 3 comma 2. Now, I want radius. For getting radius, you join this and this. What is this radius of this given circle? 4. And what is P? Take it as x1 comma y1. If we join P and the center, suppose this point is A. All of you know the property that if two tangents are drawn, then the line joining the center and the point P will bisect the angle. That is a known property of a circle. So, if this line bisects the angle above this PC is 30 degrees. Okay. Now I want PC or CP. In this triangle, you know the opposite side and this angle. Okay. So you know that 4 by CP is opposite side by hypotenuse, because this angle is 90 degrees. This is a right angle triangle. So 4 by CP will be sin 30 degrees. Opposite side by hypotenuse is sin 30 degrees. Is it not? Then what is the value of sin 30 degrees? 1 by 2. Then we get CP is equal to 8. So we got the fixed distance CP as 8. Now this is a proof that the locus of P is a circle, because C is fixed. If CP is constant, the path of P is going to be a circle with center C. So how to get the equation of the locus now? CP square is equal to 8 square, 64. What is CP square? It is x1 plus 3 whole square plus y1 minus 2 whole square is equal to 64. So if you want the locus of P, you should replace x1 and y1 by x and y. So the locus of P is x plus 3 whole square plus y minus 2 whole square is equal to 64. Clearly it is another circle concentric with the given circle. Okay. Now let us see the same steps. This is the diagram. This angle is 60 degrees. So opposite angle is 120, that is not required. Then CP is equal to 8. I explained how we calculated it. Opposite side by hypotenuse is sin 30 degrees. So we get CP is equal to 8. Then we get the locus as x plus 3 whole square plus y minus 2 whole square is equal to 64. Okay. Moving to next question. It is a very good question, very nice question. Tangents from the origin O to the circle x square plus y square plus 2gx plus 2fy plus c is equal to 0 touch the circle at A and B. Then find the equation of the circumcircle of the triangle OAB. Very nice question. All of you should remember. Suppose this is the given circle, x square plus y square plus 2gx plus 2fy plus c is equal to 0 is this. Now from the origin, suppose origin is here, two tangents are drawn. Touch the circle at A and B. Now find the equation of the circumcircle of the triangle OAB. Complete the triangle OAB. Now I want the locus of, I want the equation of the circumcircle of the triangle OAB. Now what is the center of the circle? Center of the given circle minus g comma minus f. Denoted by C. Join AC and BC. You know that the radius is perpendicular to the tangent, so this angle is pi by 2. And similarly this angle is also pi by 2. So in this quadrilateral OACB, two opposite angles are pi by 2 each. then the sum of the opposite angles is pi. If the sum of the opposite angles is pi, what is the quadrilateral? Obviously, it is cyclic quadrilateral. So, OACB is a cyclic quadrilateral. That means, same circle passing through OAB passes through C also. Is it not? One more thing is, since this angle is pi by 2, we know the property that a diameter only can subtend a right angle at any point on the circumference. Since this angle is pi by 2, OC must be the diameter of this circle. So, equation of the circumcircle of triangle OAB is given by circle with OC as diameter. What is O? O is 0, 0. Equation of the circle with OC as diameter is, using diameter form, x minus 0 into x minus of minus g, x plus g plus y minus 0 into y plus f, y minus of minus f, y plus f is equal to 0. Now, simplifying it, you will get x square here, there y square, x square plus y square, next plus gx plus here fy is equal to 0. So, this is the equation of the circumcircle of triangle OAB, right. Now, same steps I will show again. This is the diagram, center is minus g comma minus f, this is C. The required circle is circle with OC as diameter, that is x minus 0 into x plus z plus y minus 0 into y plus f is equal to 0. So, our answer is x square plus y square plus gx plus fy is equal to 0. Now, I am going to explain some theory again. Director circle, a very important concept for a circle. Consider a circle consider a circle. The definition of director circle is the locus of the point of intersection of perpendicular tangents of a given circle. A circle is given, then if you draw perpendicular tangents, say they intersect at P, then as these two tangents move, the point P also moves. Then the point P, if this angle is pi by 2, the point P moves on another circle, is it not? We have observed it in one of the previous questions. When this angle is pi by 3, P moves on a circle, concentric circle. Similarly, for this fixed angle, whatever it is, pi by 2 or pi by 4 or pi by 3, whatever it is, the locus of P is going to be a circle. But when the angle between the tangents is pi by 2, that locus of P, that circle is called director circle of this circle. Okay. Now, how to find the equation of the director circle? Let us see. For proving or for finding the formulae for this kind of concepts, we use the short form of a circle. Let us take circle with radius center 0 and radius r. This is a circle with center origin and radius r. Now, joining the center and the points of contact, let the points of contact be A and B. This is also radius of the circle. The tangent should be perpendicular. and we know that this angle is pi by 2, this angle is pi by 2. So, obviously, this is also pi by 2. So, and this angle, this side is r, this side is r. So, this length is r, this length is r. So, what is the figure formed? The figure OAPB is a square. Then, what is the length of the diagonal of the square? OP. OP will be, the length of the diagonal of the square will be root 2 times the length of the side. Length of the side is r. So, it is OP is equal to root 2 r. So, the path of P is a circle with center origin and radius of the circle is OP is equal to root 2 r. So, what is the equation of the circle with center origin and radius root 2 r? If we find x square plus y square is equal to root 2 r whole square, that is 2 r square. This is called director circle of this circle. What is this circle? X square plus y square is equal to r square. So, director circle of x square plus y square is equal to r square is x square plus y square is equal to 2 r square. So, in general, director circle of a given circle is a concentric circle with radius root 2 times the radius of the given circle. Okay. Now, the same points, locus of the point of intersection of perpendicular tangents of a circle is another concentric circle with radius root 2 times. Just now we proved it. The director circle of the circle x square plus y square is equal to r square is x square plus y square is equal to root 2 r whole square, 2 r square. Similarly, if you take a general circle with center h comma k and radius r, the equation of the circle is x minus h whole square plus y minus k whole square is equal to r square. Then the equation of the director circle will be x minus h whole square plus y minus k whole square is equal to root 2 r whole square, that is 2 r square. Same center, but radius is root 2 r. Okay, this is about director circle. Now, you have to remember one important point. The slopes of the tangents drawn from an external point P x1 y1 to the circle x square plus y square is equal to r square are the roots of this quadratic equation. I will explain how. Take the circle like this. This circle is x square plus y square is equal to r square. So, center is origin, radius is r. Now, suppose there is a point P x1 comma y1. From P, if you draw a tangent line, similarly another tangent line this side, two tangents can be drawn from an external point P x1 y1 to a circle. Now, this statement says that the slopes of these two tangents drawn from the external point P x1 y1 are the roots of this quadratic equation. How? Consider the equation of the tangent to the circle in slope form. What is the slope form of the tangent? Y is equal to mx plus or minus r root 1 plus m square. Okay. Now, it passes through P x1 y1. So, I will substitute P x1 y1. I will get y1 is equal to mx1 plus or minus r root 1 plus m square, right. Now, taking mx1 this side and squaring, y1 minus mx1 whole square equals r square into 1 plus m square. Now, if you expand the square and simplify, you will get this quadratic equation. Okay. Now, you can derive the director circle from this quadratic equation. Suppose the two tangents are perpendicular to each other. If the two tangents are perpendicular to each other, then if the slopes of these two tangents are m1 and m2, then if the tangents are perpendicular to each other, then m1 into m2 is minus 1, is it not? m1 into m2 should be minus 1. Now, from this statement, m1 and m2 are the roots of this quadratic equation. Then what is the product m1, m2? It is product of the roots of this quadratic equation. What is the formula for product of the roots? It is y1 square minus r square. All of you know the formula for product of the roots of a quadratic equation, c by a. C means term independent of m, by a means coefficient of m square. So, y1 square minus r square upon x1 square minus r square is equal to minus 1. Now, cross multiplying, we get y1 square minus r square is equal to minus x1 square plus r square. Then taking x1 square this side, you will get x1 square plus y1 square is equal to 2r square. So, the locus of the point P is the circle x square plus y square is equal to 2r square. It is called director circle, we have already discussed. Okay. And similarly, suppose the angle between the tangents is say some alpha. Find the locus of the point of intersection of the tangents to the circle x square plus y square is equal to r square, which intersect at an angle, at a fixed angle alpha. Then how to find the locus of P? If this angle is alpha, you know that tan alpha is equal to mod m1 minus m2 by 1 plus m1 m2. Now, squaring on both sides and then substituting m1 m2 and m1 plus m2 from the quadratic equation, m1 plus m1 m2 and m1 minus m2. What is m1 minus m2? Difference of the roots of a quadratic equation is, if the roots of a quadratic equation are alpha and beta, difference of the roots is given by root delta by mod A. Then you can substitute and get the locus of the point P x1 y1. Okay. And similarly, some condition may be given. Suppose two tangents of a circle x square plus y square is equal to r square make angles theta 1 and theta 2 with x axis such that cot theta 1 plus cot theta 2 is some constant k. Then find the locus of the point of intersection of those two tangents. Then also the method is same. If these two lines make angles theta 1 and theta 2 with the x axis, their slopes are tan theta 1 and tan theta 2. So, m1 is tan theta 1, m2 is tan theta 2, and the given condition is this. If the tangents move according to this condition, what is the locus of P? Then if you convert into tan, this is 1 by tan theta 1 plus 1 by tan theta 2, then taking LCM we get tan theta 1 into tan theta 2, numerator will be tan theta 1 plus tan theta 2 is equal to k. Tan theta 1 plus tan theta 2 is sum of the roots, 2x1 y1 upon x1 square minus r square, and tan theta 1 tan theta 2 is product of the roots, this. Substituting here you will get the locus of the point P. Okay. Now again some question. If two distinct chords through the point A comma B of the circle x square plus y square is equal to x square plus y square minus ax minus by is equal to 0 are bisected by the x axis, then find the condition on A and B. It is actually a previous JEE question. This is a circle. We can easily notice that that point lies on the circle. Substituting a square plus b square minus a square minus b square is 0. It is satisfied. The given point a comma b lies on the circle. So, I will take here. Now, if two distinct chords drawn through the point are bisected by the x axis. Bisected means what? X axis passes through the midpoints of these two chords. This is midpoint, this is midpoint. So, I will join them. This is x axis. Then, if two such chords are possible, if two such chords exist, then what is the condition on A and B? Now, x axis bisects two distinct chords passing through A comma B. If the other end of the chord is alpha comma beta, either this end point or this end point. If it is alpha comma beta, the midpoint should lie on x axis, is it not? We know that any point on the x axis will have y coordinate 0. What is the midpoint of these 2 points? It will be a plus alpha by 2 comma b plus beta by 2. It should lie on x axis. So, y coordinate of the point is 0, midpoint is 0. If the y coordinate is 0, then beta will be equal to minus b, right. So, now I will write this as alpha comma minus b. If you take any chord through A comma B which is bisected by the x axis, the opposite end will have y coordinate minus b, only the x coordinate will be unknown. Now, this point alpha comma minus b lies on the circle. So, I will substitute alpha comma minus b in the equation of the circle. What will I get? Alpha square plus y square means plus minus b whole square minus ax means minus a alpha, next plus b square is equal to 0. Now, I can write it as alpha square minus a alpha plus b square plus 2b square, right. We got a quadratic equation, and if two distinct chords exist, then there must be two distinct values of alpha. This quadratic equation should have two distinct real roots. What is the condition if a quadratic equation has distinct real roots? Discriminant is greater than 0. Discriminant is b square, that means a square minus 4ac means 4 into 1 into 2b square should be greater than 0. So, we get a square is greater than 8b square. So, this is the condition on A and B. Now, the same thing, I took lambda comma minus b. Instead of alpha, we can take anything lambda comma minus b, where lambda, number of values of lambda depends on the number of roots of this quadratic equation. This quadratic equation should have distinct real roots. So, condition is delta greater than 0 we get a square is greater than 8b square, right. Find the equation of the circle of radius 5 touching the line 3x plus 4y plus 5 is equal to 0 at 1 comma minus 2. First let us check whether this point is on this line or not. Substituting 3 into 1 3 minus 8 plus 5, it lies on the line. Now let us take the line like this, and the point 1 comma minus 2 is here. Touching this circle line at 1 comma minus 2, we have to draw a circle with radius 5. With radius 5, if you can draw one circle above the line, then obviously we can draw one more circle below the line, equal size. They are mirror images about this line. Now I want the equations of two circles. Find the equations of the circles of radius 5 touching the line at 1 comma minus 2. For finding the equation of circle, we need two things, center and radius. Here radius is given 5. What else we need? Center of the circle. At 1 comma minus 2, if you draw a perpendicular line, line perpendicular to the given line, it must pass through the center. In the two possible positions, if the center of this circle is C, center of this circle is C dash, this perpendicular line passes through both C and C dash. Now this distance is radius, how much? 5. You know the slope of this line. What is the slope of this line? Minus 3 by 4. All of you know the slope formula, minus a by b. So minus 3 by 4 is slope of this line. So what is the slope of the perpendicular line? 4 by 3. So slope of this line is 4 by 3. If the slope of the line is 4 by 3, by using parametric equations of this perpendicular line, we can find the coordinates of C and C dash. What are the parametric equations of a line? X is equal to x1 plus r cos theta, y is equal to y1 plus r sin theta. These two are the parametric equations of a straight line. What is x1, y1? It is a known point on the line. Take 1 comma minus 2 as x1, y1, then x is equal to 1 plus, what is this r? This distance 5. But for this point also distance is 5. So we will take r as sine distance. For one direction it is plus 5, for another direction it is minus 5. So I will take r is equal to plus r minus 5. What is cos theta? If the slope of the line is tan theta, then we can calculate cos theta and sin theta. There theta is the inclination of the line with the positive x axis. Here slope of this line is tan theta is equal to how much? Perpendicular slope 4 by 3. If tan theta is 4 by 3, what is cos theta? Constructing right angle triangle, tan theta is opposite side by adjacent side. So take this as 4, this as 3. Then what will be the hypotenuse? Root over 4 square plus 3 square, 5. Then cos theta will be adjacent side by hypotenuse 3 by 5. And y is equal to y1, y1 is minus 2. Minus 2, again r is plus r minus 5 into sin theta, opposite side by hypotenuse 4 by 5. Then cancel 5. If you take plus sign, you will get x coordinate as 4 comma 4R taking minus sign minus 2. Similarly, y coordinate of the center taking plus sign minus 2 plus 4, it is 2, or taking minus sign minus 2 minus 4 minus 6. So, taking plus sign for both, we get x is equal to 4, y is equal to 2, that is center of one possible circle 4 comma 2. What is the center of the other possible position? It is minus 2 comma minus 6, this and this. Now, write the equations of the circles, you know the center and radius. Now, I will show the same steps. This is the diagram, tan theta is equal to 4 by 3. Now, C1 or C2, centers are C1 and C2, then C1 and C2 are given by 4 comma 2 and minus 2 comma 6, then we can find the equation of the circle, equations of the two circles, right. Another question, very good question, little tough also. If two circles intersect at 1 comma 1 and 3 comma minus 1, both are tangent to y axis, find the length of AB. Take y axis like this, draw two circles, two circles are there intersecting at 1 comma 1 and 3 comma minus 1. Both are touching the y axis. They touch the y axis, it is shown in the diagram. A and B are points of contact. Then find the length of AB. Here, I will first assume that this point is P, this point is Q. Okay. Joining P and Q, the line PQ intersects this y axis at R. Okay. Now, all of you are aware of the property that if P is any point and PAB is a secant line, PA into PB is equal to PT square, where PT is this is T. We know that PA into PB is equal to PT square. Now, for point R, RP into RQ, now consider only one circle, RP into RQ with respect to this first smaller circle, first circle, RP into RQ is equal to RA square. Now, with respect to the second circle, RP into RQ will be RB square. These two must be equal. Therefore, RA is equal to RB. RA is equal to RB. So, what is R? It is the midpoint of AB. R is the midpoint of AB. Okay. We can calculate R because both the points are given now. You can find the equation of PQ and solving with y axis we get point R. After getting the point R, how to get the length of AB? Using this you can find RP into RQ is equal to RA square, you can find RA, that is equal to RB. So, length of AB is RA plus RB or 2 times RA or 2 times RB. you will get the answer. I will show the steps in a different diagram. So, that is the diagram. Equation of not PA, it is PQ. Equation of PQ will be this: x minus x plus y minus 2 is equal to 0. So, solving it with y axis, we get r is equal to 0 comma 2. Then RA square is equal to RP into RQ. RP into RQ means distance formula. Apply distance formula and calculate. You will get RA is equal to RB is equal to root 6, means RP into RQ will be root 6. So, RA is equal to RB is equal to root 6. So, the length of AB will be 2 root 6. Okay. Now, we are going to discuss the theory again. Normal of a circle. Actually, there is nothing in particular about the normal of a circle. Normal of a circle is nothing but, if you take a point P, you know about tangent. Tangent is a line which touches the circle. At the point P, if you draw a perpendicular line perpendicular to the tangent, it is called normal for any curve. Normal of some curve at some point P means a line through P perpendicular to the tangent. Now, in circle, this perpendicular line which is normal passes through the center always. Normal of a circle always passes through the center of the circle. So, any line passing through the center of the circle is called diameter, all of you know that. So, simply if you have a point P, if you want the equation of the normal, what will you do? Directly find the line joining the point P and the center of the circle. By using P, coordinates of P and coordinates of C, you can find equation of PC. So, no special formula is needed. So, normal of a line means normal of a line is nothing but line passing through center, that is all. Okay, no special formula. That is why we do not discuss any formula, just definition of a normal. Now, position of a line with respect to a circle. Suppose a circle is like this, a line is like this. This line may be completely outside the circle, or it may be intersecting line, or it may be a touching line. Three possibilities are there. Then, if the perpendicular distance from the center to the line is denoted by D and radius of the circle is R, then you observe that in the first case D is greater than the radius. In the second case, when the line is a tangent, D is equal to R. When the line is intersecting line, D is less than R. Already these points are discussed in the previous class. So, we will move on to the next point. Now, if D is less than R, the formula for length of the chord, you need to remember this. If you take a circle and a chord, suppose a line L intersects the chord, intersects the circle, then if you want the length of the chord, what is the formula? You find perpendicular distance from the center to the chord, that is denoted by D, and radius of the circle is R. So, this is R. Then we know that perpendicular from the center to the chord bisects the chord. So, this is the midpoint of this chord. If the chord is AB, this is midpoint. Now, by Pythagoras theorem, this length will be AM is equal to root over r square minus d square. Then what is the complete length AB? It is 2 root r square minus d square. It is a formula. All of you need to remember. Okay. Now another concept, chord of contact of a circle. If a circle is like this and P is any external point, from P we can draw two tangents like this. Let the points of contact be A and B. Then the line joining A and B, this line is called chord of contact of the point P with respect to the circle. Let us take point P as x1, y1 and equation of the circle as s is equal to 0. Then the equation of this line AB, which is chord of contact of P, is given by the formula S1 is equal to 0. How? S is equal to 0 means the usual form, general equation of the circle. S is x square plus y square plus 2gx plus 2fy plus c is equal to 0. P is x1, y1. Let us take A as alpha comma beta, B as gamma comma delta. Okay. Now tangents at A and B meet at P. Tangents from P to the circle touch the circle at A and B, or tangents at A and B to the circle meet at P. I will write equation of the tangent at A. Already we have proved equation of the tangent to a circle is S1 is equal to 0. So equation of the tangent at A is x1 means x alpha or alpha x plus y1 means beta y plus g into x plus x1 means plus g into alpha plus x plus f into beta plus y plus c is equal to 0. This is equation of the tangent at point A. Now similarly tangent at B is tangent at gamma comma delta is gamma x plus delta y plus g into gamma plus x plus f into delta plus y plus c is equal to 0. Right. Now both these lines intersect at P x1 y1. So we can substitute P x1 y1 in both the equations. Okay. Now I will remove this. Substituting x1 y1 in both the equations, we will get the first equation like this, second equation like this. Okay. These two are the conditions. If the tangents at P, tangents from P touch the circle at A and B, this is the okay. If the tangents at A and B intersect at P, these two are the conditions. Now I want the equation of AB. Okay. Now from these two conditions you can easily observe that the points alpha comma beta and gamma comma delta, alpha comma beta and gamma comma delta satisfy the equation xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0, right. From the first condition, alpha comma beta satisfies this equation. From the second condition, gamma comma delta satisfies this equation. So, the equation satisfied by points A and B is nothing but equation of the line AB. So, this is the equation of the line AB, which is denoted by S1 is equal to 0. Okay. Now, another concept, pole and polar. Consider a circle like this. This is a circle. Take some fixed line and a fixed circle. Now, if you take any point on this line, and draw chord of contact. Draw two tangents, then the chord of contact is going to be this line. If you draw two tangents from some point, the chord of contact is going to be this line. Now, I will draw another chord of contact. I will select another point here, and I will draw these two are two tangents from another point on the same fixed line. Now, joining the points of contact, I will get another chord of contact. This is another point of contact. Now, these two chords of contact intersect at some point. Now, the interesting point is, if you draw another chord of contact, take another point here and draw the chord of contact. Joining the points of contact, you can observe that this third chord of contact also passes through the same intersection point. That means, all these chords of contact will be concurrent at a fixed point. Okay. If you draw one more chord of contact like this, it also passes through the same fixed point. For every fixed line, there will be a corresponding fixed point with respect to a circle. This fixed point is called pole and this fixed line is called polar. Okay. Now, if the circle is S is equal to 0, if the equation of the circle is S is equal to 0, then the equation of the polar of a point P x1 y1, suppose pole is x1 y1, then the equation of the polar will be given by the formula S1 is equal to 0. See, S1 is equal to 0 is a formula for many things. It is tangent, formula for equation of the tangent, formula for equation of the chord of contact. Okay. Now, it is formula for equation of the polar of a point. Okay. How the equation of the polar is S1 is equal to 0, that we will discuss in the next class. So, for the time being, take the formula Yeah, the diagram same thing. If you take polar as a fixed line, then chords of contact will be concurrent at a fixed point. That fixed point is called pole and fixed line is called polar. Or you can also explain the polar from the pole. Suppose this is a fixed circle. Earlier we have identified the pole from the polar by taking a fixed line as polar. We draw different tangents and draw the chords of contact. We observe that they pass through a fixed point. They are concurrent at a fixed point. That is called pole. Similarly, when pole is given, how to identify the polar? Draw different chords passing through the pole. Through a given point we can draw many chords. At each point, at each end of the, for each chord, draw tangents at the ends of the chord. These two tangents intersect at some point, and again for this tangent, for this chord, tangents intersect at some point. Again for this chord, tangents intersect at some point. Now all these points of intersection will be collinear. These points of intersection will be collinear. Okay. So we can define the polar from the pole. How? The locus of the point of intersection of the tangents to a circle at the ends of any chord passing through a fixed point. The locus of the points of intersection of the tangents drawn at the extremities of a chord passing through a fixed point is a straight line. That straight line is called polar and that fixed point is called pole. And here we have defined that the chords of contact of points on a fixed line pass through a fixed point, that is called pole. Similarly, if the pole is given, this is the way to construct the polar. Okay. So we will continue the corresponding theory. There are many things to discuss about the pole and polar. So we will discuss in the next class tomorrow. Until then, all of you, I hope you are copying the notes, and every day whenever you want to attend the class, just go through the theory discussed in the previous class. Of course, I am also discussing if time permits. Okay. So we will meet in the next class. Until then, have a good day.